Welcome to Lesson 6.5, Conducting Security Testing, Password Cracking. In your Candidate Information Bulletin, we are in the Security Assessment and Testing domain. We are in Key Area of Knowledge B, which is Conduct Security Control Testing. Our topics for this lesson are going to include brute force, dictionary attacks, lookup tables, reverse lookup tables, salting, and password cracking mitigation. The objective of password attacks is to discover passwords and/or the hashing process used to store and transmit passwords. There have been numerous examples of successful password attacks over the last couple of years, including the password repositories of Kickstarter, Yahoo, LinkedIn, Adobe, Evernote, and Living Social. Password attacks either attempt to guess the password or the hash, or to reverse engineer the password hash. The two primary categories of password attacks include brute force attacks and dictionary attacks. So we're going to take a look at both of those. A brute force attack tries every possible combination of characters up to a given length. Now, if we only went 2/3 to that sentence, that would be our definition of every brute force attack. A brute force attack tries every possible combination. A brute force password attack tries every possible combination of characters up to a given length. Brute force attacks are computationally intensive. Given enough time and resources, a brute force attack will be successful. So the goal is to increase the work factor to discourage the attacker. That passwords should be long enough that searching through all the possible character strings will take too long to be worthwhile. And passwords should be changed often enough to make brute force attacks ineffective. A dictionary attack uses a file containing words, phrases, common passwords, and other strings that are likely to be used as a password. Each word in the file is hashed, and its hash is compared to the password hash to check to see if it's a match. So in this case, a repository of passwords has been captured. We take common passwords and they hash them, and then the attacker is going to compare the hash of those common or those dictionary passwords with the hashes of the repositories that have been captured. Now, a hybrid attack builds on the dictionary method by adding numeric and symbolic characters to dictionary words, such as substitute numbers and symbols for letters. So, for example, password, P-A-S-S-W-O-R-D, may turn into P, @ $, uppercase W, 0, RD. Now we're using the term hash, so let's just do a little hash refresher. Remember, hashes are fixed length, one-way representation of the original data. They're also called a fingerprint or a message digest. Now I want to stress that hashes are one-way, which means that we can't recreate the original data from the hash. In a hash attack, we're comparing hashes in order to discover the original data. Our hash functions or algorithms include MD5, SHA-256, and SHA-512. And every hash should be unique. For example, the hash of the word home, all in lower cases, you can see what the MD5 hash here would be. If I change that to the uppercase H, you'll see that the hash changes. So a hash is unique to every string, including case sensitivity. Lookup tables are an extremely effective method for an attacker to analyze hashes. Hashes are pre-computed and they're stored in a database with the plain text, so the plain text password and then the hash value. A good implementation of a lookup table can process hundreds of hash lookups per second, even when they could contain billions of hashes. Rainbow tables are a type of pre-computed lookup table. Now, a reverse lookup table allows an attacker to very efficiently apply a dictionary or a brute force attack. The attacker maps each password hash from the compromised database to a list of corresponding user accounts. And the attacker then hashes each password guess and uses the lookup table to get the list of users whose passwords were the attacker's guess. This method is effective because it's very common for many users to use the same password. Now, lookup tables and rainbow tables work only because a password is hashed the same way. And if two users have the same password, they'll have the same password hash. Now, you may recall from when we talked about cryptography that salting anonymizes the hash by appending or prepending a random string, which is known as a salt, to the password before hashing. Now, salting doesn't prevent cracking or discovery, but it does significantly increase the work factor. So some rules about salting. The salt should be generated using a cryptographically secure pseudo-random number generator so that the salts are unpredictable. The salt should be unique for each input. Salt should never be reused, and the salt should be as long as the hash function output to avoid collisions. Now, sort of our next generation of salting, there are two techniques to make cracking a password even more difficult. One is that the hash can be computed as an HMAC. Remember, a hash MAC or an HMAC is a concatenated input plus a symmetric key. Or better yet, the hash can be encrypted with a secret key or symmetric key. So we can actually take that hash and then we can encrypt it. So if an attacker was to be able to get access to the database, the password database, they would be dealing with both encryption and hashing. Both of these techniques, however, require the use of a secret key that must be managed and kept secure. So our password cracking mitigation, password discovery, password cracking, and unauthorized use can be foiled by encrypting our password hash data stores, encrypting our password hash transmission, using multiple factors. So what we're talking about here is implementing multi-factor authentication where we're not solely dependent upon passwords, and then user training, ensuring that our users are not sharing their passwords, they're not using the same password over and over at various locations, that they're creating strong passwords, they're creating complex passwords, and that they are changing them with a frequency that will allow us to foil an attacker. So let's review what we've talked about in lesson 6.5. We talked about a brute force attack, which is trying every possible combination. We said that a brute force attack, given unlimited time and resources, will eventually be successful. A dictionary attack, which is using known words and phrases and terms and hashing those and comparing those against captured password hashes. We talked about lookup tables and reverse lookup tables. Salting, which is a string that we add to our original data, our original input, when we're doing our hash. And then password cracking mitigation, which includes encryption, implementing multi-factor authentication so we're not dependent upon the insecurity of passwords, and our subject or user training. So that brings us to our lesson 6.5, match the meaning. Our terms here are brute force, a dictionary attack, work factor, a hash, assault, reverse lookup, symmetric encryption, and an HMAC. Some of these terms are new to this lesson, others are terms that we've used in previous lessons. So take a few minutes, match the meaning, put me on pause. When you're ready, come on back and we'll go through them together. Now let's go through our lesson 6.5 terms. A brute force attack is trying every possible combination. A dictionary attack compares two sets of hashes. Work factor is the time and effort required. A hash is a one-way length fixed. A hash is a one-way fixed length fingerprint or representation. Assault is a random string appended before hashing. A reverse lookup is a technique that assumes the same input. Our example here is multiple users using the same password. Symmetric encryption means that we use a single key, same key to encrypt and decrypt. And an HMAC was a hash value that included a secret key. That brings us to our CISSP exam tips. 3 things to remember. Given enough time and resources, brute force attacks will eventually succeed. Hashes are fixed-length, one-way representations of original data, and salting although not foolproof, significantly increases the work factor. So thanks for joining me for this lesson. I look forward to seeing you in our next.